Got it. Good
Okay.
morning, everyone. Thanks for joining on a Saturday morning. I see a few of you, and I see that you're at state robotics championships, I think. So thanks for joining us. I am Claire Parker. I work at DRI Nevada Robotics. Um, I am a former third grade teacher, middle school teacher. I have before this, I was over at the College of Engineering at UNR doing their engineering education outreach. And now my full-time job is, as I like to tell people, the best job in the world because I get to play with robots and hang out with teachers and students. So this session is really just how do you incorporate robotics into your classroom? And we're not asking you to add something new. We're hoping this becomes a teaching tool for what you already have to do. So quick background, DRI, most people there, they're researchers, environmental research, but there's a small group of us who do STEM education, and AJ Long and I are Nevada Robotics, and we focus on engineering, computer science, robotics as well. So, and of course, we want robotics and engineering, computer science in really pre-K through 12. It's never too early to start, which a lot of people, kindergartners can do that. Yes, and I'm about to show you how. So, all right, when you think of robots, right, what do you think of? A lot of people, Disney, right, Baymax, Wall-E, yes. Or what about the high-tech ones? We just heard about Tesla coming in and building a huge gigafactory. And of course, they have robots manufacturing. Have this. I hope it plays. So of course, while I love watching those, right, that is not what we're going for in the classroom. But I think a lot of people think of that when they think of robotics. So these are educational robots that you can incorporate in. I know I see some familiar names and faces, so I know some of you have already been working with these and incorporating those into it. But these are approachable, right? You don't need to make your robot dance and look like a human, right? Baymax, any of those. So how can we actually use these? There's a variety of ways. So let's, let's start with the story. There was an old lady who swallowed a fly, right? The sequence of that is very important. If she started with the cow, there's not really much of a story left. Computer science, it matters how you sequence your lines of code, right? And so really, this story is a great example of we already have computer science in the classroom. We just have to recognize those teaching and learning opportunities in order for us to really emphasize it, but it's there. Like you already have the tools. One of the standards is, identify and fix or debug sequences of instructions, right? You say algorithm, and there are people who get a catch in their chest, like, oh, I don't know about that. Yes, we do algorithms all the time, right? Just instructions. I think of loops. I don't know if any of you have little kids, right? But if you tell them over and over, go get your shoes, right? Like that's essentially a loop over and over. You do loops all the time in your daily life. So there's also ELA, right? Throughout this, we're going to talk about, different subjects and curriculum that you have to teach anyway. Of course, computer science is easily put in there through robotics, right? May not hit every standard for computer science, but quite a few of them. So for those of you who are not familiar with the Pigeon books, it's a crazy pigeon and has all kinds of adventures. And these that we see here on the left, little red one is a Vex 1, 2, 3. These are really pre-K to second grade, and they can get fairly advanced, right? So they start with touch coding, right? And that's just sequences for little ones. But I work with some teachers out in Elko. I see some of y'all here. Hi. But they took these books, right, with the pigeon and kind of made their own about how to treat books in the library. And I thought it was really, really just a great adaptation of something that the kids kind of already know. But then they really want to hammer home, right, that you don't like write in books or tear pages. And the pigeon, you know, that's kind of what he's doing to start. So in order to really make that connection, you can decorate this robot like a pigeon and have it act out the book. So here is an example. There's not audio on this one, right? So the pigeon's going, knocking over books. Oh no, you don't write in the books, acting crazy. So this is one of the, this is an application, right? And the kids are going to remember the robot that's dressed up like a pigeon, and they're going to remember the book as well. And oh yeah, I cannot write in the pages. I cannot tear the books or throw them down. So I thought that was a creative one. But they are going to remember key ideas and details. And that's some of the standards that we have to hit for ELA. You know, craft and structure is also in ELA as well. And those are some of the standards. So what about, you know, taking some of the books that we do, Little Red Riding Hood, right? We all know those. But then, you know, what really happened from the wolf, right? From that perspective, how does your robot, you know, if your robot is acting out Little Red Riding Hood and your robot is Little Red Riding Hood, how does that look moving across the floor or the field versus if it's from the wolf's perspective, right? So I think that can be a fun one, and you're still getting, you know, hitting that craft and structure ELA, but you're also making it where kids can connect and they can see it. Some kids cannot connect quite as well when they just write about it or talk about it. They need to see that going back and forth, and look, the robot moves in a different way because it's a different perspective. So there's also, you know, integration of knowledge and ideas are also standards that we have to hit with ELA. And so I love this book, The Mousetronaut. If you have not read it, it's awesome. But there's story time in space, right? So there's an astronaut floating around in the space station reading this book to kids. So what a great way to kind of introduce this. But the last line of the book was, you know, Meteor's already thinking about his next adventure. And Meteor's this little mouse that's the main character. And he's kind of the underdog, really. And so how about having, you know, the astronaut read that book to your students, but then, all right, you, how about you write what his next adventure is before anything else? And now we have to get our robots, right, to help get Meteor through the next adventure that the kids just wrote. This is also a great time where you can tie in, you know, what's really happening, like how is NASA really doing this? Maybe not with Meteor the mouse, but Mars exploration, right? So you're starting to get integrating also, you know, key facts as well, and nonfiction, and kind of combining those ideas. look, engineering, right? They have to make their robot do what it needs to in order to act out their story. And then, whoops, surprise, look, there actually is a second Mousetronaut book. So how did your story compare to, what, Meteor did in the second story? So there are some really creative ideas that you can use for things that you're already doing. So the color monster, I also love this one. So quick summary, the monster has so many emotions, doesn't know what to do, and is trying to sort them out, and they all have colors associated with them. But for little ones, trying to name their emotions, right? So we all have to teach SEL. So how about putting, help them decide what makes them happy, right? For this one, it's at a birthday party, or what's sad. And then they have to have their robot and program it to go to the different scenarios. And maybe instead of giving them the scenarios, you can actually let them decide what those are, work together as a group and figure it out. And then at each scenario, there's a little pom-pom or a little cup, and they just put a pom-pom in for, as they drove by it. But then at the end, now you have all of these things that they can count, right? The pom-poms, how many red do we have in here? How many blue, how many yellow, green, and then you can have them sort and count, of course, but they can start doing bar graphs with some of this as well. So you can get math in there as well, and we'll talk about more math ways as well. So it is a way for kids to bring like emotions and make it hands-on as well, and math, and start to give them the data. For those of you that teach older students, maybe the color monster isn't quite in their repertoire of what they need, right? But you can set up a robotics field, and they have to collect Mars rocks, right? And the rocks can still be pom-poms. It's really the same setup, but then what you do with it after, they can be little beads, whatever, and they're different colors. And for older ones, they have to go through and they have to actually, collect all of them in a methodical fashion, right? And then once they have all of the things, yes, they sort them, that'll be pretty fast for them. But then, what about the ratios of it as well? You can have different supplies, and, let's weigh them and see, like, what's the ratio of that? How many, heavy versus light ones, color. There are a bunch of different ways that you can do these. So for little ones, number lines, right? Adding and subtracting. I don't know about y'all, but I was not really into doing worksheets when I was little. And I definitely never liked when I had to check an assignment and the teacher would just call out like number 1, 6, number 2, 8, like, and you had to circle whether you got it right or not. I was that kid who's staring off into space, right? But what about giving kids, what is 7 minus 2, right? And their robot starts on the 7 and they have it move 2. And then there you go, it's on 5. And there's your answer. You've just checked it. Getting kids to, even before they're checking it. What about having them, if they're learning number trees, right? They can help fill in their number tree using this as a number line that they can go back and forth. Of course, you can always give it themes, right? 10 Timid Ghosts, there are cute ones with that. But Pigeon Math, that's also a great book. If you are teaching younger grades, to get them involved. And you can bring in the art part of it as well. So they can decorate their robots. For older students, there is a lot of geometry in robotics. So they, and of course, engineering as well. So the picture on the left, you'll see, this is Carson City School District. They're computer science teachers for elementary school. We did several activities with them, and they have been working with these Finch robots for a while, and it's like, oh, we've got it. And then it kept missing. This is Finch jousting. So you can kind of see it better in the second picture, but they had to build something that they could program their robot to go up, right? And then knock over the cup that had a ping pong ball on it. And they had to figure out measurements, right? How far in order to code it properly. And we did not tell them, to trace your Finch robot as the starting position. But it's something that they figured out on their own, problem solving. So that's an important part of any subject, really, whether it's computer science, math, science, even social studies and ELA. Like, you have to be able to make conclusions. On the right, this is the Vex Go. It has a field set up with it, and this one is more for 3rd through 5th, 6th grade. And the students actually build the robots, and there's all kinds of applications that you can do with these, whether it's getting the robots to run through a field, right, or an obstacle course. In the obstacle course, it starts to incorporate sensors as well. You can do it based on color, on distance, and you can tie this to some of the science standards or some of the math standards as well. Area and perimeter, that is certainly one that would be useful in solving some of these challenges. So coordinate planes, that is sometimes a hard one for students. Figuring out the negative, positive. For a lot of these, I go back to my experience. What was hard for me to learn, right? And this was one of those. And rise over run, I don't know, figuring out slope, there was a block for me. But I think if I could have seen a robot actually move, and I could see it go up and over, that would have really helped. So there are some kids who absolutely can look at it and, yep, on paper, they've got it. There's some who do better when it's 3D. And this can be a way, program your robot to go from the X to the star. Great. Now, what was the slope of that? And that is just, straight up and over. But for more advanced students, right, you can get angles in here as well. Where does the line intercept through is it through the origin? So this is a way that you can actually incorporate math in there as well. And then social studies. There's this is a really cool one. They're Ozobots. You can see them on the right. They're little. And you can use markers to code them. They follow the black line. So it's a great chance to talk to students about sensors to begin with, right? But then when it gets to red, green, red, it spins around and lights up, right? Or, green, red, blue makes it go super fast. They're all different little codes that they can put in there. But if they're also learning about the Oregon Trail, and it doesn't have to be that, it can be whatever, standard you're trying to reach, right? But the OzoBot, they have to program it to move across. But instead of just having it program and have it go, which is important, and at the same time, teaching time is short, right? You need to incorporate review in there or new concepts. So each time they get to a river crossing, there's a sheet and they have to flip it over and they have to solve it, whether it's a math question, whether it's a review question about something for the Oregon Trail, whether it's a writing prompt that they have to do. You can incorporate that in there. And I will tell you, they're going to remember it. Like, oh, do you remember when we had to cross the Mississippi and we could not get that answer right and we couldn't keep going, right? Well, that's like the Oregon Trail. They faced quite a few challenges as well. So it's a fun one. They can also decorate it. So on the far left, if you see where California is, you see the gold. That is a gold mining little car. So they can decorate those as well, or wagons. There's all kinds. And that engages kids in a different way, right? There's some who are going to love decorating, and there's some who are like, I don't care, just give me those markers and let me go to town. I want to see that robot move. This one also, yes, you can do it with markers. There is online drag and drop coding for this one as well. So it's pretty scalable. Little kids can do the markers all the way up through high school. It can get fairly advanced with these. So there's also science, right? This one is, again, it's Vexco pieces, but there's an entire lesson or a unit actually where you can go through and build from a tadpole to a froglet to a frog. And then by the end, it can even be motorized. So just because there's something, we think of robots, right? Like always moving or lighting up. And that's one of the components for a robot, right? They think, they sense, they act. But you don't have to jump right in, and try and build a little mini robot. Get the kids familiar with some of the pieces. And this is one of the examples where you can do it. You can also have them use robotics pieces, right, to build habitats and some of those. It is a great way. There are tons of books, of course, like that you can tie in. And we'll talk about implementation a little bit more, but this is part of it. Intervention. This one actually was inspired by my son. We just found out that he is dyslexic and he does not like to read. He has spent a lot of time trying to convince us that he does not need to read. And we have told him, yes, you do, but he does not want to learn his letters. And we have worked with him, flashcards, he fights it, but he loves robots. So this lesson is because of him. He is able to write any letter he wants. I always tell him he has to do more than his name because he likes those letters. But he can write those letters. He can then cut them out and tape them down on this Vex 123 field, any placement he wants, any order. And then he can place the robot anywhere he wants. And then I call out a letter and he has to program the robot. First, he has to identify where the letter is. Then he can program the robot to go there. And then once he gets to the letter, I make him say, what is the D sound? Duh, right? So now he's having to write it. He's having to recognize it. He still gets to interact with a robot, and he has to say it. And guess what? He is totally fine working on his letters now, as long as we don't do those flashcards or just quiz him. He is good with it, and he'll even ask. And that is when it's like, okay, this can truly be a teaching tool to reach kids who are fighting, not wanting to do something, or not being engaged. So this one, I promise it works. So we also have, place-based learning as well. And that can be really impactful for kids to learn about and connect with their own community. So this is one that we actually have applied for a grant. We have not heard back yet. But we, as I mentioned, DRI has quite a few environmental researchers, and two of them here, they study plastics and microplastics in the Tahoe Basin. And so we are pairing up with schools up by the lake, and the students will be presented with a challenge of cleaning up litter, right? And again, it's pretty much the same concept as before, collecting moon rocks, right? This time they do have to engineer how are they going to collect their litter, quote unquote, but they'll do it and they'll program it to go through. And then once they collect the litter, they do have to classify it. And for younger ones, it's just sorting it, by color or by object. For older ones, they are going to have to weigh it and graph it and do percentages of that as well. And then as kind of the culminating experience, they're going to get to go to beach at Lake Tahoe. And there's a company that has a beach cleaning robot, and they do cleanups. And part of what they do, everybody picks up the trash that you can see, but then their robot, you can see it on the left, digs down a couple inches and goes along, and it collects the litter that you don't normally see on the top, right? Like the bottle caps and cigarette butts that kind of get buried down there, and they collect it. And they have saved all of the litter that they have done for several years. And the researchers are going to help them classify it and figure out, okay, this type, releases these chemicals that aren't good. This one becomes microplastics, it breaks down. And the researchers are going to be there when the students are there. And they will get to do research and interact with a robot and see real world applications. I think one of the worst things that we hear as teachers is, when will I ever need to know this? This robots help with that, of course. Of course you need to know programming. You need to know how to debug, essentially problem solve. If you want your robot to be effective and do what it needs to, then you're going to have to problem solve. You're going to have to figure out sequences and loops and if then statements. And so you're going to have computer science skills in order to get any of this to work. So scalability, part of what we're proposing is to work with elementary and middle schools. And, what elementary students can do is very different than, what an 8th grader can do. But robotics can be scalable. There are certainly robots that, go, well, some of you are at state championships now, and some of those robots are big, right? And they can throw frisbees and shoot basketballs. But it doesn't have to start out that way. Little ones, they can design something the one on the right, it does have, Vex plastic pieces. You can also use pipe cleaners, right? You don't have to have specialized pieces for it. For older ones, they can build more advanced collection devices. So the other thing I would say is you don't even have to have a robot to start with computer science and incorporating that into your class. There are a lot of unplugged activities that you can do that start to reinforce computer science in there, and you can still tie it to your other standards as well. So where do you start, right? Like, this all sounds great, but how do you even start with this? So again, we do trainings all over the state, and we were doing one, and some of the teachers were saying, yeah, I have kids who are great and they're ready to go. And then I have some, I worry about them, like throwing the robot or not being gentle and it breaking. And somebody had a great idea: make them earn a robot driver's license. And so they have to be able to demonstrate that they can work well in a team. They can listen to instructions, good attitude, however you define that, whether it's perseverance or, really diving into the engineering design process as well. Respectful of robots. You can have all kinds of, helps clean up at the end. That's one of the biggest things, right? Is setting those expectations early. Because again, you don't want this to be a burden. So you would like the kids to have buy-in. If I don't help clean up or put the pieces back where they go, then we can't use them again because we don't have what we need. So the other thing I would say is start with a concept you're familiar with. If you really gravitate towards ELA, pick one of your favorite ELA units that you've done and just try one activity with it and just see. I can't tell you how many emails we get that say, all right, I tried it, I did one, and they'll, I did this intro activity and the kids loved it and it was great. And if you have not worked with robots and just the idea of computer science is intimidating, I can see where you'd be hesitant. I also know that once you see the kids light up and their engagement, I guess is the best way to put it, that's what keeps us coming back for more. And just their buy-in, and kids who, again, would kind of give up, like, yeah, it's not really for me. It is, and you can get them early. I showed the frog example, right? That one, the first 3 lessons, they're not motorized. You're not building a really complex thing all at once. Just a little tadpole at first. There are also, the activity of marshmallows and toothpicks, right? And build the tallest tower. I think a lot of us know that one. You can use pieces from robots, and the kids have to build the tallest tower using 10 robotics pieces. This is also a great one to do for older students that are just getting into it. Help them get familiar with the pieces before you're starting to have them build anything. Then they start to learn the function of it. We do recommend doing the tallest tower as one of your first activities for, young students, but also middle and high school that have not really worked with it before. It is a really great intro because there's just a little bit of competition, right? But not enough to be intimidating. It's another one where you can incorporate math each piece is, worth X amount of dollars, right? So you build the tallest tower for the least amount of money. We did this with Tesla employees, and let me just tell you, they got into it and like incredibly competitive, but the feedback at the end was, this is what we want our students to be able to do. We want optimization, right? Build the best for the least amount. That's what they want. They love the teamwork aspect. We do meet with industry partners, and they have said, and we've asked them, what skills do you want your future employees to have? And they have said, we want them to know problem solving, communication, right? Teamwork. That is something that robotics just naturally teaches students. So it's important for your students' future as well. I know robots can be expensive, right? So we do have over 600 robots that we lend out statewide. We have them all the way from pre-K up through, some competition ones. We don't have the really huge like manufacturing where you fabricate your own pieces for high school competitive, but we do have kind of the intro competitive ones that we can lend out. We also provide training for a lot of these. So if you are interested in implementing robots and finding out lessons, right? One of the things that we are really trying to do is we want to hear what your challenges are, and how in the world would you incorporate robotics and fractions? Well, like, let us know and we will help you figure that out. That is part of why we are here, is to support you. So I know we have a few minutes left, but I wanted to leave a little time for questions or ideas. Does anyone have anything? No.
I have a question. Can you hear me?
Yeah. Yes.
Sorry about the noise. So, what kind of robots do you have available at the high school level?
So we have the Spike Prime for FLL, and we also have the Vex IQ. So they're the more entry level ones. We do work with First Nevada and REC Foundation. So if it is something that you're looking to get more involved with, they do have grants sometimes so that they can help with the more advanced robots beyond what we have. So. How many of you use robots in your class? Yeah, I see some hands.
Hi, do you have a link to the lending library for the robots?
Yeah, so I will actually put this presentation. It has a link in there. Let me see, I can probably grab it. Let me stop sharing. Hang on. And I can, yeah, I can drop it in the chat as well.
Thank you.
Yeah, of course. I also have, I will put this in the chat. If you are interested about learning more about what we do or attending one of our trainings, you can put this in there. And we'll add you to our mailing list. We only use it when we're announcing a training. We don't hound you. And then let me grab the lending library. form. What age group are you looking for?
I'm personally looking for kindergarten.
My son's in kindergarten, so
They
I-
would love these activities. They look so fun.
where are you located?
I'm in Clark County.
Okay. Yep. So we do have locations in Elko, in Las Vegas, and then I am based out of Reno. But we do send robots statewide. All right, chat. And the second link is for the lending library. Anyone else? Robert, do you have a form for them to fill out or a survey?
Yep, very good. Thank you. Yeah, if you guys are still on, that's awesome presentation. It just covers so much, many different areas, and Claire's great resource. I highly recommend to get them out to you and take advantage of their knowledge. So right now, I have the session form, so I'm going to put that in the chat. So that's coming right now. All right, so there's your session evaluation for Claire, and we'll get that out to her later. So if you give her some feedback and just thanks for her time, that's just amazing resource we have in the state of Nevada. So I appreciate that, Claire. And then you folks in Vegas, I have another link for you for your PL hours. So let me put that in here. So this one should be, it is. That's your other form, and that's what you'll need to fill out at the very end of the conference today. I know Jackie's got some closing stuff going on, and she has a bunch of prizes to give out, some computers and things. Yes, even laptops. I think she has some Chromebooks donated by Samsung, and some, I don't want to let the cat out of the bag, but she has some really cool prizes. So make sure you guys jump back in the closing session. She can win some prizes. I'm not sure if it must be present to win or not, but we'll see what she says. So anyways, there's your links, and everybody a big shout out. We appreciate Claire there. And the session is recorded, so you can get back into Canvas later and pick it up in case you dropped out or you want to hear it again. Any last questions for Claire if we wrap it up, or any comments, Claire? Did you have your contact information? Did you share that?
I will put it in the chat. I also, this presentation has it as well, so I can, and I will share that so that you have links to our lending library, and some of it also has more information about some of the lessons that we've done. Some of them are online so that you can go to those.
The name of this session for some people was no experience needed. I'm reading it here. Developing robot ready educators. So no experience needed with an exclamation point. So she really wants you to be a believer in that. And then developing robot ready educators. Okay. Does somebody need me to type that, or are we good there? Hopefully you're good. I'm like a 35 word per minute typer. I can admit that. I have no shame in that. There you go. So Marianne is really good at typing and listening. So kudos to Marianne. Thank you. Okay. So they got the link to your presentation, right, Claire? And they got your email. So, and you're in the presentation, you have links to the lending library. Pretty cool.
I do, yeah.
Okay. Well, everybody's good. I think your closing ones, you have a few minutes. Claire has 5 more minutes. If you guys want to like ask her any other questions, I'll be patient and quiet for a minute. Okay, so there's my teacher wait time. All right. You guys have a great afternoon. And if you're in Northern Nevada, get out there and get that snow shoveled and stay safe and stay warm. All right. Thanks, Claire. Appreciate it.
Thanks.